Why? Hello again, and thanks to everyone who has been waiting patiently for this video. I had in fact started working on videos a few times during this project's development, but some issues came up that needed my full focus, and so the videos went by the wayside. I actually finished this project a month ago, but it's only just now that I've had some time to start making this video, so here we are. As you can guess by the intro, things certainly didn't go to plan. It lasted way longer and cost me far more than I ever wanted to put into this project, but now it's done. As there is so much to cover, I'll be splitting this video into two parts, with a second part coming within the next couple of weeks. As I mentioned in my last proper video, my goal was originally going to take this cheap Chinese Vita knockoff and gut the electronics and somehow fit a Pi into it. That of course didn't happen. Pretty early on I started to realise there would be no way to install a 2-stacked PCB in this thin chassis, not to mention any space to fit a cooler or CPU. I also quickly realised that I really hated holding onto this. It wasn't comfortable and my hands started to cramp after a few minutes. So I started off with a plan to design a chassis that would not only feel comfortable to hold, but also give enough space inside for all the electronics, batteries and cooling. I started bulking out shapes in Fusion 360, coming up with designs that had a similar face layout as the Vita clone, but making it thicker so I could fit the electronics and feel more comfortable to hold. I quite liked the rough concept that I had, so I printed a quick dummy out and see how it felt in my hands. And I could tell you it wasn't too bad at all. The majority of the buttons reach was pretty good and the grips were comfortable. So then I decided to show off the concept print to the retro gaming Discord that I'm on, to which everyone unanimously agreed that they hated it entirely. So I binned that and went back to the drawing board. After some time working on a new concept, I came up with a more organic design that included a similar layout of buttons as the Vita clone, but in a chassis that was more curved and had a more uniform shape. My goal in this design was to keep a late 80s and early 90s retro feel, as if this could have been something designed in the era of the Mega Drive. After showing this off to the Discord group, to which everyone reacted in a more positive way, I started working on some basic electronics with the layout to see if I can make this all fit. This first version of the new concept was the design I used in the mock promo I posted a few months ago, and in the edited version at the beginning of this video. I already had some basic idea of how this was going to work. I knew I needed to create a USB game controller. This will take all the button presses and the analog joystick data, and the Pi will see it as a generic controller. I've not made a game controller before, but I was aware it's a fairly straightforward thing to do with the right libraries. I had already started to source some of the components, including some really great silicon buttons that gave a proper game controller tactile response, and I even found some great low profile analog joysticks which turn out to be from the Nintendo Switch. But first I needed to settle on which Pi to use. Now, there are plenty of Pis out there, including the very popular Raspberry Pi. However, I wanted to try and save some money, and I started to discover a lot of Pi clones from China. And generally cheaper than the Raspberry Pi, they also appeared to be more powerful than the Raspberry Pi. Something I later learned which isn't actually the case, but it's what I went with for the time. And I managed to narrow down my choice between two boards, the Banana Pi Zero and the Orange Pi Zero Plus 2. Both boards are roughly the same spec, but I ended up going with the Orange Pi based on the fact that it had analog audio out. I then needed to figure out a way to get the Pi's display signal onto my display. Thanks to some foresight on my part, I made sure to get a 40-pin DPI based display. I've used these several times in the past and they're really easy to drive. I however made the wrong assumption that the Pi I picked for the project will be able to drive the 40-pin display directly through GPIO. Raspberry Pis can do this, and many projects actually use this method to drive their displays. However, I learnt during this period that when a Chinese company advertised that their Pi's GPIOs are Raspberry Pi compatible, they're lying. Turns out that this board and most Allwinner based boards do not have DPI over GPIO, so I had to come up with another method of running the display. After doing yet more research, I found the TFP401. This is an HDMI to DPI decoder chip, and even better, Adafruit already had a product using this chip, so I could use that as a design reference. I still needed to find a secure way to get the HDMI signal off my Pi and onto my board, so I came up with this design. It uses Molex board-to-board connectors, and after some trial and error, and thanks to Molex's generous sample system, I was able to find the right size connectors for a good secure fit. With the display done, I needed to sort out the audio. Almost right away I found the PAM8403 amplifier. This is a popular hobbyist amplifier with an easy to follow reference design, so that was incorporated. I then realised I needed some help with power circuits. My plan was to mainly use open designs and modules found on the internet and integrate them into my PCB design. While it was easy to find the microcontroller and amplifier designs, I was still having problems with the power system. I started off with the idea of using the battery charge and boost design from Great Scott, but I soon started to realise that this wouldn't even come close to the power requirements I needed for this handheld. I think at the time I had calculated a maximum peak and current draw of around 3.6 amps, though I would call it 4 amps to give it some headroom. Great Scott's design only had a theoretical peak of around 1 amp, but in his own tests the voltage started to break down around 800 milliamps. I had already picked a 5000 mAh battery with a 1C rated maximum draw, so I knew my battery could handle those peaks. But I still had to find a working power setup, so I got some help. I've been a member of the Freenode Electronics IRC channel for a number of years now. This is a great community of really knowledgeable and helpful people, and there are 2 people I really want to mention for the amount of help they gave me. They go by the IRC handle Viper7 and N2. Viper7 helped me lock down and understand the microcontroller design. I'm using an STM32F103 microcontroller, and while there are plenty of reference designs online, such as the one for the Blue Pill module, with Viper's help I was able to remove certain features of the Blue Pill board to maximise the pins of the microcontroller. This saved me from having to run buttons in a matrix so I could avoid ghosting or button conflicts. This also freed up some pins and other features I wanted in my design, such as the backlight control and battery level indicator. Viper7 along with N2 started to help me figure out some charge and power circuits for my design. N2 in the end came up with the working design that I have used now. But it wasn't easy. We went through about 3 different arrangements of boost and charge chips till we could settle on the design. Both N2 and Viper7 were incredibly patient with me, even when I was not the most easiest of people. Often getting frustrated with certain things not working, I relied on their help to get things done, and for that I am incredibly grateful. I must confess power circuits is an area I knew very little of at the time, but N2 really helped me a lot and taught me so much. Without their help this project would have likely ended there, which is why this next bit is so difficult to say. N2, his real name David Christensen, passed away very suddenly just a few weeks ago at the time of this recording. He was only 30 years old. This horrible news has shocked and upset not only myself, but also many of the Freenode Electronics IRC channel. David was a kind and decent person, and a brilliant electronics engineer, who would go out of his way to help many people, not only myself. He was generous, often giving hours of his time to help educate people and solve their electronics issues. It also makes making this video all the more harder for me, as David never really got to see this project in its completed state. Something I really wanted to show him to make him proud of the work he helped me accomplish, to show that the trouble I caused may have been worth it. My heart breaks for his husband Simon and the rest of his family. He will sorely be missed by all of us. Now, I had a design and at least the first revision of the PCB was on its way to me. I needed to get started making the case. My first plan was to print it on my Rodcore Got Railed FDM printer in ABS. This printer I started building last year and only mostly completing it around the beginning of this year. But I'm still having loads of problems with it, and after many attempts at trying to print this case and the printer, I gave up and split up the design to fit on my photon resin printer. But this was just the beginning of my troubles, and in the end this would be the most costly part of the project. I started off with a test print with the heavy side of each half orientated close to the build plate, and using Anycubic's brand of resin made my first prototype chassis. This meant there would be loads of support pimple scars in the grip area, which I didn't like, and also this resin, like many other cheap resins, was incredibly fragile and would easily break. But I did have my first prototype case to work with. It was around this time the first revision's PCBs turned up. I spent around 4 or 5 hours soldering and cleaning each PCB, before I could flash the STM32 with the software I already started to work on. Luckily, when turning it on, there was no smoke or bang, but it didn't appear to power up. My bench power supplier was showing a significant current draw, but nothing was running, so I assumed there must have been a short. But on testing the 3 and 5 volt lanes, I couldn't find any straight up short either, so it took me a few hours of testing to find that the short was actually coming from the EEPROM IC I used to identify the display, also known as an EDID. Now, what actually happened is I got the footprint wrong when I made the PCB design. Turns out there are 2 versions of this chip, one in an SOP8 and one in an SOT6. I got the packages mixed up on the schematic I was basing it off, and I used the pin numbers of the other chip, so in essence the chip was wired wrong and shorting to ground internally. For the sake of getting this PCB running, I used some wrapping wire and hacked the correct chip onto my board. This fixed the short, and then I discovered another problem. The backlight of my display was flashing. With this version I had referenced the backlight design of the Adafruit display board. While my circuit design matched that of the board, for some reason it wouldn't work correctly. With N2's help and the use of an oscilloscope, we figured out that the backlight's boost chip over voltage protection was being triggered, causing the chip to shut down and restart over and over. But while this was doing this, we couldn't figure out at all. So I decided it's time to work on a new revision of the board and replace this chip. I had another look at the datasheet for the display, and I noticed that it recommended a boost chip and circuit. It was a really simple design, so the PT4110 was added. It was also around this time that I realised the data line pairs on my HDMI was far from ideal, but I should say it did work, though it was probably only due to sheer luck and the relatively low resolution I was running my display at that saved it. So I'm doing some more research into differential pairs for HDMI. I then matched all the lengths from the B2B sockets to the chip as best as I could, being sure to add some ground lines between each pair. It may not win any awards for matching standards, but it was better than what I had before. Thinking the electronics were finally locked down and done, I placed a new order of PCBs and started to put together a mid-project video. But as you know, that never came out. What happened was I made several mistakes in my design, which set my project back several weeks each time. To find out what happened and to see my handheld in all its glory, watch part 2 of this project video that will be posted in a couple of weeks. Thank you for watching this video. I'll see you soon. Take care.